Hello student, how are you? I am Arun Sir, qualification Bachelor of Engineering from Jadavpur University. Welcome to my channel Tuition Expert. Today in this class I will discuss you the projection at 90 degree with inclined plane and projection horizontally from the inclined plane. Now let's start about the class. First discuss projection at 90 degree with inclined plane. Suppose this is a plane, inclined plane. This is inclined plane. Okay. Now here a body is projected at 90 degree with velocity u. This is 90 degree. A body is projected from the inclined plane at 90 degree with the inclined plane. Suppose this angle is theta. Now what will be the path of the projectile? Like this. Path will be like this. Okay. Now here you have to calculate the time of flight and range. Time of flight and range. Range will be this. We know the range is this, and time of flight, time taken to reach from A to B. So here the important things is just select x and y axis. We select this x axis, this along x axis and this along y axis. We select the inclined plane is x axis and perpendicular to the line, that is this is y axis. So first of all we have to resolve the velocity along x and y direction and the acceleration also x and y direction. Acceleration and velocity. Now if this is x and this is y, then velocity along x direction, initial velocity along x direction, what? 0, ux 0, and uy is u, and this is the velocity part, and this is the what is the acceleration part? Acceleration ax equal to, now what is the acceleration? Acceleration due to gravity, x vertically downward. Okay. If this angle is theta, then from this is also theta. How? This is theta, this is 90, this is 90 minus theta. So 90 minus theta is theta. So this angle is theta. Now what is the component of g along this? Component of g along this is g cos theta, and this is g sin theta. We know this is g sin theta, g cos theta. So acceleration along x axis equal to g sin theta, and acceleration along y axis equal to minus g cos theta. Always we have to resolve the velocity and acceleration along x and y direction. Okay. Now we know, first find the time of flight. First time of flight. So time of flight, to find the time of flight, we know that the displacement along y axis is 0. Displacement along y axis equal to 0, because initial position is here and final position is here. So displacement along y axis is 0 in time t, that is the particle after time of flight. After time of flight, displacement along y axis is 0. So put the equation. Always we put the equation this. Always we put the equation this. Equation of motion means always we use the equation in straight line. There is no equation in curved path. That is, this path is combination of vertical and horizontal. So always we, any curved path, suppose this is a curved path, so we resolve this curved path. Actually there is no equation along curved path. We always use equation in straight line. So this curved path is equivalent to this horizontal path and this vertical path. So always we use the equation along straight line. So for this curved path we use along x direction, use the equation along x direction, and we use the equation along y direction. So there is no equation along curved path. We always use the equation in straight line. So along y direction, if you use the equation, what is the equation? A is equal to ut plus half at square. We know. So uyt plus half ay t square. This Now what is UY? UY equal to U. AY, what is AY? This. So if cancel T, we get time of flight is. So this is the time of flight. Now what is the range? Range is here displacement along, okay, displacement along x-axis, because we take x-axis at here, x-axis this is, so displacement along x-axis, that is sx equal to r, you know, uxt plus half x square. So we always use the equation in straight line. Ux equal to 0 here, t plus half ax, x equal to, and t, what is t? T equal to this. So this is the answer. So this is the answer. So range will be this. So we use the equation in straight line. First we resolve the velocity along x and y direction. Then we use the, first we find the time of flight. First we find the time of flight. Then we can find the range. So next topic is projection horizontally from an inclined plane. Projection horizontally from an inclined plane. Next topics. So this is a plane. This is a plane. Now we throw the body with velocity u horizontally. This is theta. Now the path will be like this. Path will be like this. This is the path. So A and B. This is the range. This is the range, and this is the time of flight. Here also we find the time of flight. Time of flight and range. Time of flight and range. Also, now one condition. Also we find the most important condition. What is the condition to strike the plane vertically? That is with perpendicularly. That not perpendicularly. It is not perpendicularly. Now find the time of flight and range. So here we take, this is x-axis and this is y-axis. This is x-axis, this is y-axis. So we first resolve the velocity and acceleration along x and y direction. So velocity along x direction, this is u and this angle is theta. So obviously this angle is theta. Now along x-axis component is u cos theta, and here velocity is u sin theta. We know u cos theta. So ux will be u cos theta, and first we get the two component of the velocity. Now we get the two component of acceleration. What is the acceleration here? Acceleration this g. Now along vertical, along y, parallel to y, that is this, and this. So this component, this is theta, this angle is theta, so this is g cos theta, again this is g sin theta. So we get ax equal to g sin theta and ay equal to, y direction is this, so negative y axis, so this is minus g cos theta, we get this. Now to find the first time of flight, again the displacement along y direction is 0, so uy t plus half ay t square equal to 0. Okay, so uy equal to u sin theta t, ay equal to g cos theta t square equal to 0. Take common t, g cos theta into t by 2 equal to 0. Now t equal to, here there are two value of t. First t equal to 0, t equal to 0 means at here, so t equal to 0 is at here, and for so actually sy equal to 0 at two position, here and here. Here correspond the time t equal to 0 and here correspond the time of flight. So from this we get t equal to, so this is the time of flight. Okay, so this is the time of flight. Now range, obviously range equal to displacement along x-axis. So you just simply use the equation of straight line, ux t plus half ax t square, simple equation in straight line. Ux equal to, we get ux, what is ux was u cos theta along x direction. U cos the time of flight we get here, this plus half ax, what is x equal to g sin theta into t, means 2u sin theta by this. Okay, this is the result. If you simplify, then some result may come. So this is the procedure to find the range along inclined plane if horizontally strike the ground. Now two problem. Now let's discuss about what is the condition to strike the particle at inclined plane perpendicularly and also horizontally. So this is the important point. Most MCQ comes from this point. Suppose this is an inclined plane and a particle is projected at an angle u with inclined plane. Then if the path, obviously the path of the particle will be this. Now the question is here, if the particle strike the plane perpendicularly, find the range of the particle. Here range means this distance A to B. Question understand? This is an inclined plane. If a body is projected with velocity u at an angle theta with inclined plane, and if it strike the plane perpendicularly, then what is the range of this particle? You have to answer the range in terms of u and theta. Okay, now let's find how to find the range. The range is r here. I told the things many times, repeated many times, that when you solve the problem related to inclined plane, always resolve the velocity and acceleration in x and y direction. So you have to take the x and y in two convenient direction. So here one direction along r, so we have, this is x axis, we take this along x axis and this along y axis, vertical line. So this is, we take along inclined plane as x axis, and so perpendicular to the line is y axis. Now we first resolve the velocity. So velocity along x, obviously u cos theta and uy, sorry, now velocity along x direction, obviously initial velocity u cos theta and uy equal to u sin theta. Understand? Very simple things. ux equal to u cos theta, uy equal to u sin theta. Now what is acceleration? Acceleration is here. Acceleration is always vertically act downward. Now this angle is theta, so obviously this angle is g cos theta and this angle is g sin theta. Obviously this is g, so this angle is theta, so this component g cos theta and this component is g sin theta. So we write here ax equal to g sin theta and ay equal to minus g cos theta. Okay, now use the equation in straight line. So what is the condition? Here question is the particles strike the plane perpendicularly. So what is that condition? Perpendicular. Now perpendicularly strike means that is here also two velocity, here also two component of velocity, one x, suppose this is velocity, so if we along component, this is vx and this is vy, so this is v, suppose final velocity. Now condition is that the particles strike the plane perpendicularly, that is vx should be 0. Vx perpendicular means if particles strike perpendicularly, then we must have vx equal to 0. Okay, fine, understand? Vx equal to 0. Here velocity along x-axis 0 because the particles strike completely perpendicularly, so vy present, vx 0. So now what is the vx? V equal to u minus at. So here ux plus ax into t equal to 0. So ux equal to what? U cos theta minus ax equal to ax. What is ax? Ax here g sin theta along this direction. So we take x-axis along this and acceleration along this. So here ax will be minus g sin theta into t equal to 0. From that we get t equal to u cos theta by g sin theta. Okay, this is the t, time of flight, t. Now, so this is the condition. If the body strike the perpendicularly, so after that time the body strike the plane perpendicularly. After that time body strike the plane perpendicularly. Fine. Now at that time what is the range? So range, we to find the range, now what is that range? Range means displacement along x direction, sx. So this equal to ux t plus half ax t square, which is ux is u cos theta into t is this plus half ax is this. Ax here we take here x-axis along this, but acceleration along this direction. So ax equal to minus g sin theta and ay also minus g cos theta. So acceleration always minus g sin theta here. So ax equal to minus g sin theta into t square. T is this. Now if we simplify, then we get a simplified result. One minus half equal to half. So this is the answer. Square cos square theta by g sin theta. So this is the range. Simplified result. This is the range. So first we find condition of perpendicularity, that vx here 0, vy. So after time t, time of flight, after time this time, the body strike perpendicularly. And now to find the range, we have to calculate the displacement along x direction, this direction in time t. So we use the equation at here. So this is the result. Okay. Now projectile is projected with speed u at angle of 60 degree with horizontal from the foot of an inclined plane if the projectile hits the inclined plane horizontally the range on the inclined plane will be this is the question. Now I repeat the question once again. A projectile is projected with speed u at an angle of 60 degrees horizontal from the foot of an inclined plane. If the projectile hits the inclined plane horizontally, this is the special case. Horizontally, the range on inclined plane will be what? These are 4 options. Which one is correct? So if we draw the picture, suppose this is an inclined plane, this is ground, a body is projected with velocity u at an angle 60 degree with horizontal from the foot. Suppose with the horizontals, that is this angle is, this is the ground, and from the ground this angle is 60 degree. Okay, this angle is 60 degree. Now what is the range? The range will be this. Now if the velocity at here is this, so this is completely horizontally. Now strike the horizontally, so Vy must be 0. So if this is Vx and this is Vy, so here condition is Vy equal to 0. Complete Vx, only Vx present means present, that is strike the plane horizontally. Strike the plane horizontally means Vx present, Vy 0, Vy must be 0 here, Vx present. So now this is the condition, so that condition you have to find the range. Okay, now what is the question? Now we take along x and y axis, along this is the x axis and this is along y axis. This is, we take this normally with this x and this y axis. This is x axis, this is y axis. So first find x, so first find ux equal to what? U cos 60 degree, Uy equal to U sin 60 degree. This, now acceleration, this is g at this, so this and this are the 2 component. This is 60 degree, so this g cos 60 degree and this is g sin 60 degree. So acceleration along we take here x-axis this, so we don't have to resolve this. Now we take, this is x-axis and this is y-axis, so acceleration is completely vertically downward, so we acceleration along x direction is here 0, x 0, and ay is minus g. Okay, now first we find the time. First we use the condition to horizontal, it strike the inclined plane at horizontally. So first use the condition that the particle strike horizontally must be 0. Now what is Vy? Vy equal to Uy minus Uy t equal to 0. Uy equal to, what is Uy? Root 3 U by 2. Ay equal to minus g into t. So t equal to root 3 U by 2g. So this is the time of flight. Now we have to find the range. So to find the range, we calculate this and this distance. Suppose this is A, B, and this is C. So we can easily calculate AB. AB equal to what? Because we know the velocity along this direction. So velocity along this direction is U cos 60 degree into T. That is U by 2 into T. This is a AB, and BC is along y direction displacement. So BC equal to actually displacement along y direction, which is equal to UIT plus half AYT square. So UI means this into T means this plus half AY is minus g into t square. T square means t is equal to this, so 3u square by 4g. Now what is the result? Result is 3u square by 4g minus 3u square. So this is the g square. So 3u square, g1 cancel, 8g. So this is equal to 3u square by 8g. So we get BC. BC equal to this and AB equal to this. So we get now from Pythagoras theorem. We can find the range. So range R equal to here, R equal to AC square equal to AB square plus BC square. So what is AB? AB equal to this plus BC equal to this. R square equal to this is 412. So this is the answer. Students, this is the end of the class. Subscribe my channel to get more and more videos. Welcome. Thank you. Okay.